Problem 89, a relatively challenging problem. This is a calorimetry problem. You got some unknown metal, it's 14.9 grams. You heat it up to 100 by putting it in boiling water, no doubt, and you drop it in 75 grams of room temperature water, and it goes up 8 degrees. From that, you can figure out the specific heat of the metal. The key to these problems is realizing that any heat that was lost by the metal was gained by the water. So we're going to find the heat that the water gained. That's the heat that the metal lost, and from that we can solve the problem. It's strange that you have to do this, but only does the Q water involve a known specific heat. If you try to do it any other way, you just don't have enough data. So first find the heat that the water gained. Use these subscripts W's to keep track of things. We're dealing with specific heat. The specific heat equation is Q equals mc delta T. You should memorize that. Q is heat, m is mass, c is specific heat, and change in temperature is delta T. So mass of the water was given 75 grams. Specific heat of water is something you can look up. It's 4.184 joules per gram per degree Celsius for liquid water. Note that you're going to have to maintain those units, joules, grams, and Celsius. We're good on grams. And the change in temperature was 8 degrees. Therefore, the amount of heat that the water gained was 2,510.4 joules. That must also come from the hot metal, so assuming perfect insulation, which we do. We can plug that in. We have the mass of the metal. We have the change in temperature of the metal because it started at 100 and it went down to 28. And so we can solve now. Plug in your 2510.4. The mass of the metal is given. The change in the temperature of the water is a little hard to see, but remember it started at 100 and it went down to 28. It clearly didn't go down to 20. It went down to 28. That's 72 degrees. Therefore, the specific heat is 2.34 joules per gram degree Celsius. Oftentimes they have you look that stuff up at a table to identify the metal. If you get a number that's not between like 0 and 4, you've probably screwed up because almost all known substances fall into that range. That's problem 89.